Okay, section 4.1, apply triangle sum properties. First of all, we need to know how to classify triangles by sides and classify triangles by angles. Okay, we have three ways to classify by sides. Scalene, there are no congruent sides. Isosceles, two of our sides are congruent. And equilateral, all three sides are congruent. Classifying triangles by angles. I have an acute, all angles are acute. A right triangle, one right angle. Obtuse, okay, one obtuse angle. And equiangular, all angles are congruent. First example, classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. So if you look closely here, this triangle right here, it's been marked. Okay, those two tick marks, if you remember, mean that those sides are congruent. So this is an isosceles triangle. And then by sides, if you were to measure these with your protractor, okay, you measure this one right here, you would know that this one is 55 degrees. That one is 55 degrees. And this one up here is actually about 70 degrees. So I have three angles. Two of them are equal. They're all less than 90 degrees. So this is an acute isosceles triangle. Classify triangle PQO by its sides. Then determine if the triangle is a right triangle. First, I'm going to determine if the triangle is a right triangle. We're going to do the second part first because it's sort of the easier part. Okay? When things are graphed, you know they are right when they are perpendicular to each other. Okay, segments form a right triangle when two segments are perpendicular to each other. So we can actually count these segments. Okay, this one right here, if I count, I have rise over run, so I get a rise of 2 and a run of -1. This one right here, a rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2. So a rise of 1 and a run of 2. And this one, the slope up here is rise of 1, run of 1, 2, 3, 4, 5, 6, 7. Rise of 1, run of 7. This slope and this slope are opposite reciprocals. Therefore, it's perpendicular. Yes, it is a right triangle. Okay, now let's do the harder part. Classify triangle PQO by its sides. Okay, so we need to know the length of each side. And the way we find out the length of each side is distance formula equals x2 minus x1 squared plus y2 minus y1 squared. And we have to do that for each side. So this length with these 2 points, this length with these 2 points, and sorry, this length with these 2 points, and the last length. We're going to have to calculate the length of PO, OQ, and QP. So I'm just going to plug them in. PO, I have 0 minus a -1. That is x2 minus x1 plus 0 minus 2, quantity squared. Calculating that, I'm going to just give the answer. I get 2.2. OQ, x2 minus x1. Show you that. Whoops. OQ, x2 minus x1, 0 minus 6 squared plus 0 minus 3 squared. And that gives me 6.7. And QP. Q 6 minus a negative 1. 6 minus negative 1 squared plus 3 minus 2 squared. And I get QP 7.1. Okay, so what kind of, if I classify it by its sides, I have a scalene, because none of them are equal. Scalene. So it is a right scalene triangle. Alright, you try. Push pause. So first I drew an obtuse isosceles triangle. I marked it because sometimes it's hard to know. Okay, these are equal. I put a tick. And this angle is greater than 90 degrees. Secondly, I drew an acute scalene triangle. So all the sides are different measurements, even though it's hard. Like this actually looks like an equilateral triangle, but I've marked it so that all sides are not equal. And then I just made a note that all angles are less than 90 degrees because, well, it looks like they're all less than 90, but you can never be sure. Triangle ABC has the vertices given. Classify it by its sides, then determine if it's a right triangle. You can either graph this to count its slope, or you can calculate the slope between each point. What you're going to want to do is give me the distance of AB, the distance of BC, and the distance of AC. Then you're going to want to find the slope of AB, the slope of BC, and the slope of AC, and compare the slopes. Okay? I forgot to tell you to push pause and then find the answer. Okay, I have my three sides. 1, 2, 3. 2 of them are equal, so I'm isosceles. Isosceles. My three slopes, 1, 2, 3, 2 of them are opposite reciprocal, so I do have perpendicular sides. So it's an isosceles right triangle. Alright, here we have when the sides of angles. When the sides of a polygon are extended, other angles are formed. The original angles are the interior angles, which I'll color in red. Okay, these are the interior angles of a triangle. Okay, it's interior. The angles that form linear pairs with the interior angles are the exterior angles. Color them all in. Those form linear pairs with the interior angles because if you remember, the word linear is a line. So if I fit this puzzle piece and this puzzle piece together, they form a line. Linear is a line. If I fit this puzzle piece together with the interior angle, I form a line. Okay? So those are all exterior angles, the blue ones. I have 6 exterior angles and 3 interior angles. Theorem 4.1, the triangle sum theorem. The sum of the measure of the interior angles of a right triangle is 180. So I have, this is the measure of angle A, the measure of angle B, and the measure of angle C. Add all of those together and you're going to get 180. Auxiliary lines. To prove certain theorems, you may need to add a line, a segment, or a ray to a given diagram. An auxiliary line is used in the proof of the triangle sum theorem, which we're going to do next. So I have a triangle there. Okay, I just need that auxiliary line drawn on top. parallel to this to help me do a proof. You know, I can draw an auxiliary line anywhere. I could draw a ray here, that's an auxiliary line. I could draw a ray there. I could draw a line here, you know, parallel to this one. I could draw anything. Okay, we're going to do a proof. It's a triangle sum theorem. Given triangle ABC, we're going to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay, first I'm going to write a plan. Okay, a plan is just going to help me figure out what to do and in what order. So first I'm going to draw an auxiliary line. Auxiliary. Okay, and that line, I'm going to draw that so that it's parallel with AC. Then I'm going to show that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. Okay, we also know that angle 1 is congruent to angle 4 because alternate interior, and angle 3 is congruent to angle 5 because alternate interior, angle theorem. So we're actually going to say by substitution that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So it's not going to be too hard. So let's go. Step 1. We're actually going to say this. Draw BD, line BD parallel to segment AC. And our reason there is going to be the parallel postulate. Okay, step 2, just like our plan, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. Oh, that should be 1. Sorry about that. And my reason for number 2 is angle addition postulate. In the definition, that's an F. Of straight angle. We've never used that one, huh? Then we're going to say that angle 1 is congruent to angle 4. Angle 3 is congruent to angle 5. And that's the alternate interior angle theorem. So we know the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 3 is equal to the measure of angle 5. This is a reason that it sticks a lot of us, the definition of congruent angles. And then last but not least, we can use substitution to say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees because of substitution. All right. Moving on, the exterior angle theorem. The measure of an exterior angle, which is that one, is equal to the sum of the measures of the two adjacent non-adjacent interior angles. So the measure of this is equal to that one plus that one. And let's write that down. So we know the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Alright, so let's find the measure of angle JKM. So we know that that's an exterior angle, and this angle equals this one plus this one. So 2x minus 5 equals x plus 70. Some algebra. I'm going to subtract x from both sides. And then so I have x equals 75. Not done though. I need to plug that in. 2 times 75 minus 5 is 150 minus 5, which is 145. Alright, corollary to a theorem, a statement that can be proved easily using a theorem. The corollary below follows from the triangle sum theorem. So the corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. This is sort of a duh theorem. I say that because the triangle sum theorem said the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Well, here I have the measure of angle A plus the measure of angle B plus 90, because C is 90, equals 180. So the measure of angle A plus the measure of angle B equals 90. This is your two acute angles of a right triangle are complementary. Duh. Alright, let's try this one. The tiled staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle. Okay, the measure of one acute angle in the triangle is twice the measure of the other. So really, you need to be able to do this on your own. Okay, the measure of one angle is twice the other. Find the measure. I can use the corollary and say 2x plus x equals 90. 3x equals 90, x equals 30. So this one is 30 degrees, this one is 60 degrees, and you're good. You try. Push pause. Okay, we know that x is 25, but we are not done. Go ahead and finish it. I know that the exterior angle is 115, but we're still not done. Using a linear pair, being supplementary, you know that the measure of angle 1 is 165. But I'm going to go ahead and change to red pen and show you one other way. I could plug in 25 for x here and get 75. And then you could add 75 and 40 using the exterior angle theorem or the interior sum theorem and finish that one. Another you try, push pause. X equals 30, but you're not done. Alright, there you go. If you see anything wrong with this answer, let me know tomorrow and I'll give you a bonus point. Find the measure of the acute angles in the right triangle in the diagram shown below. You can either use the corollary or not. So x equals 32, but you're not quite done. And there are your two answers. Okay, in example 4, which you'd have to go back a little bit, what is the measure of the obtuse angle formed between the staircase and a segment extending from the horizontal leg? Hold on a second, I'm going to give you a few pointers. Okay, let's go back to that example. We learned that x was 30. So we know that this is 30. And we're actually asking what this angle is. So 180 minus 30 is 150. That's the answer. Okay, your daily homework quiz. I'll give the answers tomorrow. You can check your work and turn it in for 2 extra credit points. There's number 1, number 2, and number 3. Good job. Oh, wait, sorry. Number 4. I'll see you tomorrow. Good job.